All right, we've got some FAQs here for pre-calculus for section 5.2, day 2. And I'm just going to warn you right up front that 45 is not for the faint of heart. It really isn't. This is a tough one, and this would be tough for somebody who's been doing trade for quite a while to make this one work out. I actually sat down and tried for an hour to figure out an easier way to go through this proof than the way that the book had it. And I'm just not seeing it at this point, so we really would need to do what the book has on this one. You can try and do the educated cheat, which is, work backwards a little bit from this, change it all into sine and cosine, but eventually you're at a stalemate. I mean, you really are. So one of the things that I first did was start with this, just to get an educated cheat about where I was going to go with this. Make it 1 plus 1 over the cosine of x times 1 over the sine of x. And then think, okay, well, if I write this as a common denominator, and I were to try and get these two things together, I would have to multiply by cosine of x sine of x on both the top and the bottom, and still add my 1 over cosine x sine of x. So we have cosine x sine of x plus 1 over cosine of x sine of x. And really, that's where we're trying to get to. The problem is, it is really tough to get the other side of this to match that. So I'm going to start with tangent of x over 1 minus cotangent of x plus cotangent of x over 1 minus tangent of x. And the first thing that we definitely try is changing some of this into sine and cosine, in fact all of it, because this is a mess. We don't have any Pythagorean identities we can use with this. So tangent is sine of x over cosine of x. And then we have 1 minus cotangent is cosine of x over sine of x plus cosine of x over sine of x over 1 minus sine of x over cosine of x. And again, one of the first things that I had tried was to get a common denominator out of all of this and then see what would happen. It doesn't work. It just doesn't. So we do have to go the way that the book had this solution, which is it's not going to be pretty, but what we're going to do is we're going to multiply by the sine of x on the top and the bottom. Now, you think, why on earth are they doing that? Well, what they're trying to do is get rid of fractions in our denominator. And so we see we have a sine of x down here, and that would make perfect sense for this one. But for the other fraction, they multiply by the cosine of x over the cosine of x, and that makes perfect sense for getting rid of the denominator of the bottom fraction. So we're really looking at this as having fractions within fractions. So in the numerator, it's going to be sine squared x over cosine x when we multiply that by sine of x. In the denominator, now that we're multiplying that by the sine of x, we will have sine of x, because we still have to multiply it by 1, minus cosine of x. And hopefully now you're starting to see why they went this way. I mean, at least we're a little closer to being rid of fractions than we were before. So over here now, we would have, let me put that down a little bit so you can see the top there. We would have cosine squared x over sine of x. Make that look more like a plus than an equals. And 1 times cosine x would be cosine x, and then these two would cancel out, minus sine of x. Now, I don't know about you, but the first thing I noticed was, doggone it, we would have a common denominator right now if we could just switch those around, if we could just somehow do that. Well, we can. We're going to go ahead and leave this one, sine squared x over cosine of x, over sine of x minus cosine of x. But with this one, what I'm going to do is I'm going to factor out a -1, and that, of course, would reverse this. And when I factor out that -1, I could use that to make this subtraction instead. All right, so now we're going in the right direction, but we still have a fraction in the numerator, and we have a denominator that we have to deal with. And so we keep thinking, okay, how am I going to get this to match what I need for secant and cosecant? And I want you to look right up here, and that's the hint. The hint is that we're going to need this to be sine of x and cosine of x. The only way we're going to do that is by introducing it right now, because we don't have it. We have sine of x minus cosine x for both of these. So we are going to have to multiply our numerator and our denominator by the sine of x, cosine x, in order to manipulate this. So that educated cheat that I did was a little useful. Not incredibly useful, but it was useful to give us a hint about what we have to do. So we go ahead and multiply this out, and there is some good that comes out of this, because now what we're doing is we're getting rid of a denominator in our numerator, because these two cosines are going to cancel right out, but now we'll have sine cubed x over sine x minus cosine x times sine of x cosine x. And we will have a subtraction, and then we will have sine of x canceling out here, and we will get cosine cubed of x over sine of x minus cosine x times sine of x cosine x. All right, so now we have that piece that we needed for the denominator, but something really weird has happened. We now have a cube in our numerator. And we do know how to factor the difference of two cubes. So our hope is that when we factor out that difference of two cubes, that we will be done with this. That's what we need to get rid of. So you need to remember your formula for the difference of two cubes, and that's a minus b times a squared plus ab plus b squared. And in this case, a would be the sine of x and b would be the cosine of x. So in our numerator, we will have the sine of x minus the cosine of x, which is great news because look at our denominator. We're going to be able to cancel that. But what we would have left would be sine squared x plus sine x times cosine x plus cosine squared x from the second portion of that fraction. So one good thing just happened. We're going to have sine of x minus cosine of x will be cancelable. We will be able to cancel that out. And that will finally mean that we have the denominator that we needed to get to make this a match. So now, what on earth are we going to do with sine squared x plus sine x cosine x plus cosine squared x? Well, we're going to put these two together and make that a 1. And now, we want to see what this is. And what we want to do is separate it out to see if we can get it to match. Well, let's go all the way back up here. Take a peek at that educated cheat. And look what we have. So we want to separate this in order to get everything to work out nicely, which means we want to do the division for both of those terms so that we can get it back where it needs to be. So we are now at the point, once we made that denominator match, where we can go ahead and use the educated cheat backwards. So this will be, if we have 1 plus sine of x cosine x, well, 1 divided by this is going to be 1 over the sine of x cosine of x, plus this divided by this, which is 1. And then we remember, okay, they wanted it in the other direction, but 1 over the sine of x, that would give us cosecant. So let's move that one behind. And 1 over the cosine of x, well, that would give us our secant. So this would be 1 plus secant x cosecant x. And like I said, I'm not going to give up on this one. It very well may be that I'll find another way that we can factor that, but truly they went after it the right way. We need to figure out how to get rid of all of those fractions within fractions. And so what they did was they tried to figure out how to get rid of denominators in both the numerator and the denominator. And unfortunately, that brings us a cubic. And when we have that cubic, we've got a difference. I kept wanting to say a difference of 2 cubes. And we do know how to factor that. It's just not the most pleasant thing in the world to have come along with our trigonometry. Then the next one on your list was number 48. And in number 48, we have 1 minus 3 cosine x minus 4 cosine squared x over sine squared x. And somehow we want that to become 1 minus 4 cosine x over 1 minus cosine x. So here's what we need to do. We're going to take a peek at it, and hopefully we'll notice that this is factorable. The numerator is definitely factorable. And that factors to where we see, well, we need a 1 in the front, so obviously that's going to be 1 and 1. And you need to kind of think of this as 1 minus 3y minus 4y squared. And then I think it'll go a little bit easier, because in the back, the numbers that we would have to work with would be 1 and 4 or 2 and 2. And 2 and 2 would not give us what we need. So if we have a 1 plus 1 cosine x minus 4 cosine x, outside times outside will be a negative 4 cosine x. Inside times inside will be plus 1 cosine x. And it will work. Last times last will give us 4 cosine squared x. Now, we had that sine squared x on the bottom, and at the same time, I'm going to go ahead and change that into cosines, because I notice that the answer is just cosines. So now I have this as part of my answer, and I realize, well, the denominator can be factored now too. So my numerator and my denominator, both in factored form, because 1 minus cosine squared x is a difference of 2 squares, and these two will cancel out. And that gets us exactly what we need. So kind of an awkward factoring, kind of factoring backwards up there, that probably messed with some people as you were trying to think your way through that one. Number 54 is the next one on your list, and it says match the function with an equivalent expression from the following list, then confirm the match with a proof. It says the matching is not 1-to-1. So if you're unsure about which one you should be trying to work your way towards with this, remember what we talked about in class, and that is if you graph it, they should end up one right on top of another, and that would help you figure out exactly where you're going to go. So what I'm doing is I'm thinking about that list that I see up there and how I'm going to make that happen. And most of the time when we don't know where to go, it's just a really good idea for us to go ahead and change this into sine and cosine. So we would have 1 over cosine squared x plus 1 over sine squared x. And that would be a good place for us to start to see what's going to happen. And then, of course, we would want to get ourselves a common denominator and see what this looks like when it's put together. So we would multiply by sine squared x on the top and the bottom, and cosine squared x on the top and the bottom, because really we're just multiplying by 1. So sine squared x over sine squared x, cosine squared x, plus cosine squared x over sine squared x, cosine squared x, and we can put those together. Sine squared x plus cosine squared x over sine squared x, cosine squared x. And hopefully, when you saw that, you were thinking, wait a minute, that is 1 up there on the top. That is one of our trig identities. It absolutely is. And then, because these are the reciprocals, 1 over, we'd say, okay, well, what do we have here? We've got 1 over the sine, and that's going to be cosecant, and 1 over the cosine. But when you look at the answers, it probably makes more sense to think, you know what, I'm just going to take those 2's off of there and put a big squared up at the top. Either way, it doesn't matter. In fact, for me, the book kind of put that step in there, but it just makes more sense for me to say, well, 1 over sine squared x, that's going to be cosecant x, and then 1 over cosine squared x is secant, and they wanted secant first for their answer. So we would go ahead and write secant squared x and cosecant squared x. And then we have one of them out of the way. So again, not a bad idea to graph them and see which one does this match up with, so that you know where it is you're trying to go. What is the answer that I'm actually trying to figure out? Number 57, 1 over secant of x minus tangent of x. Alrighty, so what to try? Well, we know from past experience, all we really have here is a denominator, and what we would want to do is try the conjugate and see if that does anything for us. See if that gets us anywhere. Alright, so now we'll have secant x plus tangent of x over, and it'll be secant squared x with first times first, and then minus tangent squared x. Now that the bell rang and everything is situated again. So, as I'm looking at this, I'm thinking pretty obviously this is going to have something to do with secant of x and tangent of x. And so I started thinking, well, what could I do here that might help me out with getting just one piece of this? Well, I can certainly split this back up now and say secant x over secant squared x minus tangent squared x plus tangent x over secant squared x minus tangent squared x. Now, why do that? Because once I have it split up, now I can make the first fraction all about secant, and I can make the second fraction all about tangent by using my Pythagorean identities. And then that will give me a better feel for what I'm trying to prove here. So secant x over, and again, this one would be all about secant. So what I'm going to do is I'm going to replace this tangent with secant squared x minus 1. And then in the second fraction, I'm going to replace secant squared x with 1 plus tangent squared x. Whoops, missed a little plus there. Do that from time to time because you've got the plus tangent, and they'll both look like t's eventually. And then we're going to subtract that tangent squared x that's already there. So we're just replacing those pieces in the hopes that this is going to clarify what's going on. So now, the denominator of this one will be secant squared x minus secant squared x plus 1. And this one will be 1 plus tangent squared x minus tangent squared x when we drop the parentheses. So this is gone, and we have secant x plus, and this is gone, and we have tangent x over 1, which is tangent x. And that was one of the identities that they wanted us to prove up there. Again, with these, if you want to know which one you should be working towards, graph them all and see which ones graph right over the top of the others. Now 77, skipped 59 here. The equation, the square root of x squared equals x, is an identity. Justify your answer. Well, let's see here. Here's what we know. that the square root of x squared is really the square root of x times the square root of x. Now when you multiply two square roots together, you get a square root. And x times x will give you x squared. And the square root of x squared is x. So that would be a justification for our answer, an algebraic justification of what we're doing. About with this is the domain, because we want to make sure that we're always going to have numbers that would be in the domain. So we'll go back and talk about the square root of x squared, and if that's going to be something that's possible that we're able to do, then x is greater than or equal to 0 is going to have to be our domain. And when we look at what we have for an answer, that would make sense. We need those domains to match as we work through there. And I was just looking up, I thought we had another one on another day where we were talking about the domain and how those domains have to match. I remember doing one of those on another FAQ, making sure that the domain stays the same. Number 77. With this one, it's just kind of awkward because it says confirm the identity, and we're thinking, okay, wait a minute, what is up with this absolute value business? Well, all we have to remember is, just like anything else, if you're working with absolute value, then you have to stay within absolute value unless you have a good reason to leave, and you want to consider the domains. So with this one, I noticed what they want me to prove involves sine and cosine. So what I would do is split this up and say, well, it's the absolute value of the sine of x over the absolute value of the cosine of x. And that's going to be the natural log of, and then we'd have the absolute value of the sine of x over the absolute value of cosine of x. Now that's important because what we want to do next is separate those. And in the language of logarithms, division means subtraction. So that will be the natural log of the absolute value of sine of x minus the natural log of the absolute value of cosine of x. So we're just using the properties of logarithms along with remembering that we're working with absolute value here. It's similar to what we do when we're working with square roots or, in fact, any kind of root. And that is that you can only work within the same index. So in this case, we're working within the absolute value group, and we're also working within logarithms. So we can follow the properties of logarithms and keep it true as far as absolute value goes.